So you can take your water and you can add acid to it, bring the pH down, and the organics will be removed more favourably. However, downstream processes such as filtration work better at neutral pH. So then, having brought the pH down, you've then got to add lime to bring it back up in order for your other processes to work optimally. So actually, it's not really just a simple balance like that. It's a three-way balancing act. You could argue it's far more than three actually, but I've just gone for three. Microbial compliance, disinfection, byproduct compliance, and the cost. The first talk, Derek talks about the value that we place upon water. None of us like our water bills to go up, none of us want bugs in our water, and none of us want disinfection byproducts at a concentration which may well do us harm. So it's a three-way balancing act, and I haven't mentioned in this energy consumption or chemical consumption, so you could say there's more points to this polygon. So it's a tricky situation. It's not a all doom and gloom though, and I must change the title of this slide because I actually think we should be celebrating rather than looking at failures. But each year there's the DWI have samples taken of about 1.3, I think it is, million different samples of water and tested against 40 different parameters, THMs being one of them. And this graph here shows how many samples have failed those tests since 1992. And I can't, for the life of me, remember the 2008 number, but I do know that in 2007, 99.96% of those samples passed their tests. So the water companies have a challenge. The water companies have a challenge of compliance, whether it's microbiological or whether it's chemical. They have a challenge over their carbon footprint. They have a challenge over their resource usage and the cost of water treatment. And that's a challenge that's not going to go away. One might argue that there shouldn't be a bar there, it should be down at zero. And statistics and such like, I think, preclude that from ever happening. But people would argue that perhaps it should be lower. But water quality, potable water quality, is a significant challenge to the water companies. What then can we do about it? If we look ahead, what should we be doing? I think the first thing is to look at source control. Where are we getting raw water from, which we then treat, and what's happening to that raw water in the environment? I've mentioned organic matter being a precursor to THMs. Can we manage the environment, and can we manage our sources in a better way to reduce the concentrations of organics so that we reduce the issue of THMs? I would say these because I work in research, but we need more research to look at improved treatment processes for water treatment. And a subject that's particularly close to my heart is we need to improve our capabilities at modelling THM formation in water treatment works and distribution systems, so we can predict, looking at the raw water, what the level, what concentrations of THMs may well be at customer taps, having gone through different treatment processes and distribution system in order to enhance our management of the systems. But all of this, of course, comes at a price. We've already heard this evening about the cost of water and the value of water. We need, I believe, we need sustained investment in our water infrastructure. We benefit from the fact that our water infrastructure was put in place 100 years ago, but it's also a bit of a millstone for us because it means we've got so many sunk assets worth billions of pounds that we can't actually redesign everything from start. So we need to maintain investment within our water treatment works and indeed our sewage treatment works, distribution systems and sewage systems, to make sure that water companies can continue to provide the quality of water that they have been doing in recent years. One final thought to leave you with, though, it's quite an old quote now from the World Health Organization. I've talked about the balance between THM compliance and microbiological compliance. The World Health Organization are quite clear on this subject, though. Efficient disinfection must never be compromised, and that's simply because E. coli in the water can do us a lot of almost immediate damage, whereas brief exposure to a chemical contaminant may not have the same immediate consequences. As if you remember, I was talking about long-term low-level exposure. So efficient disinfection must never be compromised. Ladies and gentlemen, thank you very much for being such an attentive audience.
John had a very clear account of what is evidently a very complex business, and probably none of us have been so aware of how much complexity there is in it yet.
I have a question about those exponential curves.
Yeah.
Do they mean that there is any difference if I spill some water from my cup, if I drink it immediately, or if I let it stand like 1 hour?
No, generally not, because of the way water treatment works and water distribution systems work. We see a very rapid decay in chlorine actually at the water treatment works during the disinfection stage in a large concrete box at the works. By the time it's got into the distribution system, there are still reactions ongoing, but they decay with time because the rate decays with time because the chlorine decays with time. By and large, by the time the water gets to your tap, it's relatively inactive.
At what stage is fluoride added to the water? At which stage?
Right. I've got to preface that with no two water treatment works are the same. So it depends, and water treatment works is designed to depend on an awful lot of things, one of which is corporate preference. My experience shows that fluoride is added early on, before most of the other treatment processes. So I don't know how familiar you are with the treatment process, but quite early on indeed.
Can I just ask in relation to a question about chlorine?
Yeah.
It degrades over time, chlorine of itself, yeah, but I understand that it's not actually chlorine that you're adding to it routinely now, it's compounds of chlorine which doesn't evaporate.
We will add a chlorine gas. It tends to be used at large water treatment works. At smaller water treatment works, we tend to use a salt, hypochlorite salt.
Mm.
So I just talk about hypochlorous acid, where you get that in a salt form, and then add water to it.
Is it true though that chlorides don't evaporate or degrade to the same degree? And that's why you've switched to chlorides rather than chlorine.
You're right in the rate equation. Yes. The choice of disinfectants, which I think is really what you're getting at, will depend upon quality of water and ability to be able to ease a bit of the easiest way of meeting the required quality standards. So, for example, we don't put chlorine gas at small rural water treatment works. Because there are all sorts of health and safety implications of chlorine gas, you don't want to be maybe tampering volumes of chlorine gas out of small installations. So we'd use, let's say, hypochlorite salts.
But my actual question is related to the long-term accumulative health effects of chlorides rather than chlorine. There doesn't appear to be any health studies relating to compounds, complex compounds of chlorine.
I can't point you at any. But
I can't find any.
Part of the body. Chloride ions are a normal part of the body.
Well, most things are to one degree or another, but it's all relative, isn't it? Is the point.
Quite a lot of chloride in there. I'm going to ask all our speakers now to come to the front, and those of you who haven't perhaps asked your questions have still got the opportunity to do so. So if you can just bring out another chair. Two chairs, and I'll stand, I think, and I can see everyone. Thank you. Right, it's now open to the floor to ask questions, comment, or contribute as they wish.
Yeah, basically it says here that it's criminal offence to supply water that's unfit for